Hi, Wonder Class, and welcome to our maths lesson on Friday, the 5th of February 2021. So, starting off our lesson, can you have a go at carrying out some of these arithmetic questions? So, remember, you can pause the screen, have a go at recording, timing yourself to see how long it might take for you to do these questions. I'll read the questions to you. So, number 1 is 3 times 3. Number 2 is 1,345. Add 3,333. Number 3, what is today's date as a Roman numeral? Number 4, what number is next in the sequence? 45, 41, 37, 33. Number 5 is 9 times 7. Number 6 is 64 divided by 4. Number 7 is what is 500 millimeters in centimeters. Number 8, what is 3,000 meters in kilometers. Number 9, what is 9:20 p.m. on a 24-hour clock. And number 10, what is 54 divided by 6? So have a go, pause the screen. When you press play, I will then show you the answers. Okay, so you might have had a chance to carry out these questions. I am going to go through the answers with you. So number 1, it equals 9. Number 2 equals 4,678. Number 3, V11MMXXI. Number 4, 29. Number 5, 63. Number 6, 16. Number 7, 50 centimeters. Number 8, 3 kilometers. Number 9, 21, 20. And number 10, 9. So let's have a look at what we're learning about today. So today we're looking at, can I explain fractions that are greater than 1? So the first thing I'm going to get you guys to do is have a go to use these digit cards to make as many equivalent fractions as you can. So I will give you one example of equivalent fraction. I would choose the number 1 and 2. So I'm going to make a half, and I know a half is equivalent to 6/12. See if you can make some more equivalent fractions. So you might want to have a go doing this on a whiteboard, and then you could take a picture and then post it onto Tapestry. So today we're looking at what happens to a fraction that is greater than a whole. So you can see here that the numerator is larger than the denominator. So what essentially we're trying to find out is what makes the parts that make this whole. So let's have a look over here. There are 7 quarters in the diagram. So altogether, there are 7 quarters because we're looking at each line. So each line consists of 1, 2, 3, 4, which makes the denominator number 4. But then how many are shaded in is 1, 2, 3, 4, 5, 6, 7. So in total, we've got 7 quarters. But how will we split that up? So we've got one whole, and we know that one whole will be 4 over 4. So it will be 4 over 4, which is the same as a whole. And then how many do we have shaded in this quarter? We've got 3, so it'll be 3 quarters. So we know that one whole at 3 quarters is 7 quarters. So 4 quarters equals one whole at 3 quarters, and the same what I just said is 7 quarters. So how would you split up this fraction so that it becomes some wholes and some parts? So you can have a go at this, pause the screen, see if you can work it out on your own given my one explanation, and then press play and I will show you exactly how we work this out. Okay, so let's have a look at what we've got here. So we have to look at each row on its own. So what we don't do is we don't add the rows. So we don't say there are 3 rows with 5, which makes 15. It's not going to be 15 our denominator. We just look at one row as an individual. So our first row has 1, 2, 3, 4, 5, and the other 3 rows also consist of 5, but they're all separate rows. So our denominator is going to be out of 5. Then we need to look at how many are shaded in. So we've got 5 shaded in here, another 5 which makes 10, and 3. So that's 13. So it would be out of 13, so 13/5. But how do we split it up? We have to look at what we've got up here. So we've got 2 wholes. So 2 wholes is 10/5 because if we count it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 shaded in as wholes, and they're out of 5. And then what have we got on the last row? We've got 3 shaded in out of 5, which is 3/5. And then if we add the numerators together, 13 add sorry, 10 add 3 equals 13. So in total, our whole is 13 fifths. So complete the part whole diagram. I am just going to explain this to you. So it says, what are 9/5 the same as? So in this one we have here, we've got 1, 2, 3, 4, 5. So it's out of 5. And then we've got 9 shaded in, so 5, 6, 7, 8, 9. So it's 9/5. But how do we split it out? So we have to look at our rows as individuals. So our first row is showing us whole because the whole thing is shaded in. So that makes 5/5, which is the same as a whole. Then we look at the second row, you can see that 4 are shaded in and 1 is not, so it's 4/5. And if you add the denominators together, 5 add 4, it equals 9, which is how you get your whole in your part whole model, 9/5. So let's have a look at the next one. We've got 3 rows, and in each row we've got 4. So our denominator is going to be 4. Remember to look at the rows as individuals. How many holes do we have? We've got 2 holes because 2 of these are shaded in completely. So 2 holes, so 4 and 4 is 8, so it's 8/4, which is the same as 2 holes. And then we've got our final row, which has 1 shaded in, which shows us a quarter, or one quarter. Now, if you add the numerators together, 8 plus 1, it equals 9, which makes your whole from your parts 9/4. So it's kind of like addition, but you're breaking it down using the rows to check. So here is a question for you to have a think about. It says, Jessica says, it is impossible for me to have more than 4/4 of pizza, as a pizza is split is as a quarter is a pizza split into 4. Do you agree with Jessica? Explain your answer to a partner or maybe to somebody around you. Sketch a picture to help you explain what do you mean. So it is impossible for me to have more than 4/4 of pizza, as a quarter is a pizza split into 4. So have a think about that question. Okay, I'm going to show you what the answer could look like. So let's say, and I think I've shown you this before. So we have a pizza. So a pizza is in a circle shape, which makes our whole. And remember, when we split it up into quarters, we're splitting it into 4. So any quarter you split it up to is always going to be 4. So we know that if we split the pizza in half, we have 2 quarters. So this makes a quarter, this makes a quarter, and we can go back to our fraction rule to remember how we see what quarters and halves do. So if I split my whole pizza makes 1. If I split my pizza in half, I would have a half. So a half would be, this shaded area would be my half. So this would be the half. Now, what does a half make up of quarters? So we could have a look. This is a half. Now, if we take that piece of half and we put it into the quarters, we have 2 quarters. And if we take the other piece of the half, we have another 2 quarters. And we know that 2 and 2 is 4. So essentially, a pizza cannot have more than 4 when split into quarters. It only has 4. So whatever it is that we're folding, be it a square piece of paper into quarters, we would only end up with 4 quarters because we know that 4 quarters makes 1 whole. So here are your activities for today. So you've got 4 challenges to complete the sentences, to have a look at the part whole model. Question number 2 is to shade the bar models to represent the fraction that you can see. Question number 3 is complete the statement. So how many holes are in the fractions that you have in front of you? And number 4, Whitney bakes 26 muffins. Muffins are packed in boxes of 4. How many boxes can Whitney fill? So have a think. How would you work out that wording? Question. Have a go, and we will go through these questions in our Friday Live. Good luck, everyone. And remember to use your fraction rule if you get stuck.